You think cause and effect is the most basic rule of reality. First this happens, then that happens. A pushes B. A switch flips. A room turns bright. Fine. But what if the universe doesn't actually agree on what first means? Not as philosophy, as physics. So let me show you. Start with something you've done 1,000 times. Clap your hands. Just one clap. You feel your palms collide. You hear the sound. You see the motion. It feels like one clean chain. Hands move, hands hit. Sound happens. Now move that clap far away. Stand on one side of a football field. Put a friend on the other side. You clap. They watch. And something subtle breaks. They see your hands meet first, and only after that, they hear the sound. Here's the number that locks it in. Sound moves at about 343 meters per second. Across a football field, the delay is a few tenths of a second, about 0.3 seconds. Light, on the other hand, is basically instant. Across that same distance, the delay is a few hundred nanoseconds, around 0.000003 seconds, so your friend doesn't experience the event. They experience signals about the event arriving at different times. And that's the first crack. There's a difference between reality happening and reality being known. Think about that. Because your brain treats those as the same thing. You feel like you experience the world directly. You don't. You experience information arriving. And if information arrives late, your sense of order changes. Now you might shrug and say, sure, sound is slow, fine. So let's remove sound. Let's use the fastest signal we know, light. Light moves at 299,792,458 meters per second, about 300,000 kilometers per second. In 1 second, it could circle the Earth more than 7 times. That number isn't just impressive, it's a boundary, because it's not merely how fast light goes, it's the fastest speed at which anything can update anything else. It's the fastest speed at which cause can reach effect. And the moment you accept that, you get a dangerous implication. There are events so separated that no influence can connect them in time, not even light. So what does it mean to say one caused the other? But wait, how could reality ever fail to agree on order? How could before depend on perspective? To see it, you have to let go of something you didn't realize you were assuming. You think simultaneous is real. You think it's a property of the universe. Two things happen at the same time. End of story. But same time isn't something you find in nature. It's something you construct using clocks and signals. And that construction depends on light. Here's a clean way to see it. A long train moves past you at high speed. Inside the train, a person stands exactly in the middle. There's a light at the front of the train. There's a light at the back. Now imagine both lights flash. In the train's frame, the person in the middle receives both flashes at the same time. So they say, those flashes were emitted simultaneously. But you're standing still on the ground watching the train move, and you see something else. While the light is traveling, the person in the middle is moving. They're moving toward the light coming from the front. They're moving away from the light coming from the back. So you expect the front light to reach them first. And here's where the usual explanation gets confusing if you say it wrong. So let's say it cleanly. So here's what's happening. In the train's frame, the flashes are emitted at the same time. In the ground frame, they are not. In the ground frame, the back one fires first. So by the time the person meets both signals, they arrive together. Both views are internally consistent. And the reason this is even possible is one fact. The speed of light is the same for everyone. It doesn't add with your motion. It doesn't subtract with your motion. It behaves like a structural rule. And to preserve that rule, space and time can't stay fixed. Measurements of time and distance adjust with motion, not as a trick, not as an illusion, as geometry. Different observers moving relative to each other will disagree about what events happened at the same time. Not because someone is wrong, because simultaneity isn't universal. The universe doesn't give you a single clock. It gives you local clocks and rules for translating between them. So now you've lost the thing your intuition was standing on, a universal now. There is no global present moment slicing the universe into one shared time. There are only local nows. And once you lose universal now, you lose universal ordering, because before and after depend on how you slice time. Now you might say, okay, fine, simultaneity breaks, but cause and effect still survives, because surely nobody disagrees on causality. A cause must come before its effect, right? But wait, protected by what? If time ordering isn't absolute, what enforces cause before effect? Before we answer that, notice something. When you say two events are simultaneous, you're doing something hidden. You're comparing clocks in different places. And that comparison is not free. It requires a method. So let's expose the method, because this is where now stops being a feeling and becomes an algorithm. Imagine two clocks. One is here with you, the other is far away down the track. You want to know if they read the same time. How do you do it? You can't hold them side by side. You have to synchronize them across distance. So you do the obvious thing. You send a light signal. Clock A sends a flash to clock B. Clock B receives it and sends a flash back. Clock A receives the return. Now you define the rule. You say the moment clock B received the flash happened halfway between my send and receive times. That sounds harmless. That sounds like common sense. But notice what you just assumed. You assumed the signal took the same time going there as it took coming back. You assumed light speed is the same in both directions. You assumed that the universe lets you define a shared now across distance. And in your daily life, that assumption works so well you never even notice it's an assumption. But the train thought experiment is telling you something. Once you're moving fast enough, the same synchronization procedure produces different answers depending on who is moving. Because the signals don't land on the same slices of time anymore. What you thought was the present was actually a convention, a construction, a computed relationship between events based on how light travels. So when two observers disagree about what was simultaneous, it's not because reality is unclear. It's because simultaneity is not something the universe hands you, it's something you build, and your building material is light. There isn't a universal clock ticking behind the scenes. There are only events, and there are signals connecting events. Time is how you label the events so the signals make sense. And now, once you accept that, the next part becomes unavoidable. If now is local, then causality is local too, because causality is nothing more than what can reach what, which means we're finally ready for the real structure. Here's the key. Causality is not a rule floating above reality. Causality is a map of what can influence what. It's built from one constraint. Information has a maximum speed. So imagine any event, a spark in a wire, a neuron firing, a star exploding, a button clicked. That event happens at one place and one time. Now ask the only question that matters. What parts of the universe can that event affect? The answer is only what information can reach. So the event's influence spreads outward like a growing bubble. The sphere expanding through space. Its boundary moves at light speed. Inside the bubble are places the event could affect. Outside the bubble are places it cannot affect yet. That expanding boundary is what causality looks like. And now you can say the structural reframe out loud. Cause and effect isn't just a story, it's the structure of space-time. It's geometry, Causality isn't a story, it's a boundary. Now here's where it gets stranger. There are two events in the universe so separated that neither can influence the other. No signal can travel between them fast enough. Not even light. They sit outside each other's causal reach. And in that situation, the universe doesn't owe you a single correct order. Different observers can disagree about which happened first. Not because reality is confused, because ordering only matters where influence is possible. And now comes the line that makes everything click. Outside causal reach, first is not wrong, it's undefined. Read that again. If no influence can connect two events, then which came first is not a factual question. It's a question that only has meaning inside a causal structure. Your intuition hates this, because your intuition expects time to be a single river. But the universe doesn't run on a single clock. It runs on constraints. Now you might feel the big problem, but wait. If order can flip between observers, doesn't that mean effects can come before causes? Doesn't that imply paradoxes? Here's the safety lock. If event A can influence event B, if a signal can go from A to B, then B lies inside A's causal future. And that relationship cannot be reversed without breaking the speed limit. So causality is protected wherever it matters, inside the region where influence can travel. The only place order becomes ambiguous is precisely where causality doesn't apply anyway, because the events are disconnected. That's not hand-waving. That's the structure of space-time doing the policing. So at this point, causality looks less like a mystical rule and more like a practical consequence of a speed limit. But here's the part most people miss. They hear speed limit and think it's a limit on rockets. They think it's a limit on engines. No, it's a limit on relationships. It's a limit on what can affect what even means. And the reason it becomes so deep is because light doesn't just set a maximum speed, it forces time and space to trade with each other. So before we go to proofs, we need to look at the engine behind the boundary, because the boundary exists for a reason. And that reason is that motion through space-time has a fixed structure. Here's another way to see it. Imagine you build a clock out of light. Not a mechanical clock, a pure clock. Two mirrors facing each other. A photon bounces between them, up, down, up, down. Each round trip is one tick. In the clock's own frame, the photon travels straight up and down. Simple. Now, imagine that clock moving sideways past you at high speed. You're watching from the outside. What path does the photon take now? It still moves at the speed of light. It has to. But the clock is sliding sideways while the photon travels. So from your perspective, the photon doesn't go straight up and down. It goes diagonally. It has to chase the moving mirror, which means the photon travels a longer distance per tick, but its speed hasn't changed. So if the distance per tick increased, the time per tick must increase too. That means the moving clock ticks slower, not because anything is wrong with the clock, not because it's broken, because the geometry forces it. The speed of light stays fixed, so the only thing that can change is the relationship between space and time. And this is the moment where you should stop and feel what just happened. Time slowing down isn't a weird consequence. It's the simplest way to keep the universe consistent. If you insist that light moves at the same speed for everyone, then moving clocks must run differently. There is no other option. And once you accept that, you realize something even stranger. It's not just clocks, it's everything. Any process that takes time is a clock. Chemical reactions, neural firing, atomic vibration. If time runs differently for you, it runs differently for all of those. So time dilation isn't a special effect, it's a structural feature of reality. And now the causality boundary becomes even clearer, because what you call before and after is built out of how signals travel and how clocks tick. When the ticking is relative, the slicing is relative. The only thing that stays absolute is reachability. The only thing that stays objective is, can a signal get there? That's why causality survives, because causality isn't the story you tell. It's the wiring diagram that tells you which stories are even allowed. Now, there's one more piece of the geometry, because if time stretches, space has to respond too. If you move fast enough, distances in your direction of motion compress, not because space is squishing like rubber, because distance and time are linked by the same conversion factor. And that conversion factor is the speed of light. So you don't get one fixed space and one fixed time. You get space-time. A single structure with different slices depending on motion. And if you want to see why distance has to change too, imagine a ship moving so fast that it can send a pulse of light to a mirror in the front and back. In the ship's frame, both distances are equal. The pulses take the same amount of time. Everything is symmetric. But from the outside, the front mirror is running away from the forward pulse, and the back mirror is moving toward the backward pulse. If space stayed the same, one trip would take longer and the other would take shorter, and the ship could measure its own motion just by timing light. That would break the whole structure. So space-time does something cleaner. Lengths along the direction of motion contract in exactly the amount required to keep the timing consistent. Not because objects are squeezed by force. Because distance at a moment depends on which slice of time you're using. That's why the speed limit isn't just a number. It's the rule that forces space, time, and measurement to stay coherent. And now we've earned the full meaning of the causality bubble. It isn't just a metaphor. It's the actual shape of influence in space-time. And you can test it, you can measure it, you can build systems that break if you ignore it. Which brings us to proof. GPS, satellites orbit Earth carrying extremely precise clocks. Those clocks don't tick at the same rate as clocks on the ground. They tick differently because the satellites are moving fast and because gravity is different up there. And the numbers are not subtle. If you ignored those timing shifts, GPS would drift by kilometers quickly, roughly 10 kilometers per day. Not by inches, not by a little error, by the kind of error that makes your phone place you in the wrong neighborhood. So every time your map works, you are witnessing the absence of a universal clock. You are seeing engineers treat time as local and correctable. You are seeing causality as a real constraint, not philosophy. Now look at the deeper point. GPS is basically a machine for comparing signals. Your phone is receiving timestamps from satellites, then calculating where you must be based on how long those signals took to arrive. It is literally constructing now out of light speed messages. And it only works because the structure is consistent, because the boundary is real. Now for a second proof, something you can't dismiss as just electronics. Look up. Above your head, right now, space is throwing particles at Earth. Cosmic rays hit the upper atmosphere at enormous speeds. When they collide, they create unstable particles. Particles that decay quickly. Their natural lifetime is tiny, about 2 microseconds, 2 millionths of a second. If you take that number seriously, common sense says they should vanish long before they reach the ground. And yet detectors on Earth's surface measure them anyway. So what happened? Did they break causality? No. Time itself behaved differently. Because at extreme speeds, the way time and distance fit together changes. From our perspective, their lifetime lasts longer than 2 microseconds. From their perspective, the distance to the ground is shorter. Either way, the universe makes the same prediction. More of them reach the surface than everyday intuition would allow. This isn't poetic language. It's measured. The sky is running a relativistic experiment above your head every second. Now add one more proof that hits even harder, because this one shows the boundary as resistance. In particle accelerators, we take charged particles and push them with electromagnetic fields. We keep giving them more and more energy. And something strange happens. At first, they speed up the way you expect. More push means more speed. But as they approach light speed, the relationship changes. You keep adding energy, and their speed barely changes. Instead, what increases is their momentum, their inertia. It becomes harder and harder to change their motion, not because the machine is weak, because space-time won't let velocity climb past the boundary. So the speed limit shows up as a kind of geometric wall. You can lean on it, you can throw energy at it, and the universe responds by reshaping time and distance relationships rather than letting you cross. This is why faster than light isn't just difficult. It's not expensive. It's not, we haven't engineered it yet. It's asking for influence without a valid structure. It's asking for effects without a reachable future. And that's what makes it meaningless. Now, we can bring everything together. You started with a simple belief. Cause comes before effect everywhere, always. That belief works in your daily life because your daily life lives inside a tiny region where speeds are slow, distances are small, and signal delays are negligible. Your brain evolved in that pocket, so it treats the pocket as the whole universe, but the universe is larger than your pocket. And when you step outside it, even just intellectually, your model starts to fail. Here's the complete reframe in one sentence. Cause and effect doesn't break down because reality is chaotic. It breaks down because causality is not fundamental. It emerges from space-time structure and limits on information. Say it even more simply. Causality is what you get when events can reach each other in a consistent order. When those conditions hold, cause and effect becomes a reliable rule. When they don't, the rule dissolves. Not into anything can happen, into something stricter. Some questions stop being meaningful because causality is not a story you can tell everywhere. It's a boundary you can draw, and the boundary is set by light speed. Now, there's one last mistake people make right here. They think the speed of light is a special property of light. It isn't. Even if light didn't exist, the boundary would still exist, because the boundary is a feature of space-time itself. It's the maximum rate at which this can affect that. Light happens to travel at that rate because it has no rest mass. But the rate belongs to the structure, not to the messenger. So when you ask, what stops effects from happening before causes, the answer is no longer mysterious. What stops it is that a cause is only a cause if it can reach its effect. And reachability is bounded. If you try to violate that bound, you're not bending a rule. You're asking for a relationship the geometry doesn't allow. You're asking for influence without time, for connection without a path. Not hard, meaningless. Now, at this point, you might think we've reached bedrock. We haven't, because even inside causal limits, the universe has another way to resist the story your brain wants to tell. Not by violating the speed limit, by refusing to give you a neat, this pushes that chain. I'll show you quickly, and then we'll return to the core. Imagine you and a friend share a system created together. Then you separate far apart. You each measure something on your own side. The results are random individually, but when you compare notes, the outcomes are strongly correlated. Not perfectly, not identical every time. The weirdness is subtler and stronger. The correlation pattern is too structured to be explained by chance alone, and it breaks the classical limit you would expect if each side were running on preset local instructions. That's the key phrase, preset local instructions. Your intuition tries to rescue causality by saying both outcomes were decided in advance. But the correlations don't behave like that. And yet no signal is traveling between the two measurements, because the measurements are separated in such a way that even light couldn't connect them in time. So you're forced into an unavoidable conclusion. Some connections in nature don't look like cause and effect chains. They look like shared structure. And there's a safety lock here too. You can't use this to send information faster than light. You can't choose the outcome you get. You measure and you receive a random result. The correlation appears only when you compare both sides afterward. So the universe doesn't let you build a time machine out of it, but it does force you to admit something. The classical picture-tiny causes pushing tiny effects through space is not always the right story. That isn't the main point today. It's an edge case, a warning label, a hint that causality might be an emergent pattern, not a fundamental ingredient. Now put that aside. Because there's one more place, causality becomes fragile. Not because of quantum weirdness, because geometry itself can become extreme. So extreme that the very shape of reachability changes. You think space is a stage, a passive container. Things happen in it, time flows through it, cause and effect plays out on top of it like a movie. But space-time isn't a stage. It's part of the system. It bends, it tilts the possible paths that signals can take. And if it tilts far enough, you can create a boundary made out of causality itself, a region where escape stops being a future option. Not because light slows down, but because every future directed path points inward. It's like standing on terrain where every step forward is downhill. Once you cross that boundary, the universe still has cause and effect locally, but the rest of the universe loses access to your future forever. Information can't come out. Not in practice. In principle, that's what a causal boundary really is. It's geometry deciding what can reach what even means. And now you can feel how far we've come from a hand clap. You started with first, then, and you ended with this. Causality is terrain. It is the structure of space-time drawing the edges of influence. Now bring it back. Bring it all the way back to the real point, because the real point isn't extreme gravity or quantum experiments. The real point is the quiet thing you saw across a football field. Reality is not instantly connected. Events are stitched together by signals, and signals have a maximum speed. That's why now is local. That's why first can become undefined. That's why cause and effect isn't a universal commandment. It's an emergent pattern inside a causal structure. So here's the final reframe. Cause and effect doesn't break down because reality is chaotic. It breaks down because causality is not the foundation. It's a pattern produced when space-time supplies three things: a speed limit for influence, a consistent geometry of reachability, a stable direction of future inside that geometry. When you have those, causality feels absolute. When you don't, the idea starts to dissolve. Not into nonsense, into a deeper order your intuition wasn't built to see. And the fact that we can see it at all, the fact that we can map it, test it, build systems that depend on it, that's the miracle. Not comfort, not simplicity, truth. And if causality is emergent, if it's a boundary drawn by space-time, then the next question isn't, can we break it? The next question is deeper. Why does time feel like it has a direction at all?